Okay, so let's suppose there are two charge particle and magnitude charge is, this is q1, this is the q2, and they are separated by, by distance r. Okay guys, and so, due to charge, force between them arise. Okay, due to this charge, force between them arise. Okay, and the magnitude of this force is, F is equal to magnitude of this, let me write down magnitude of this force is, F is equal to k q1. I am not going to write down, sign of charge, q1 q2 by r square. Okay guys, so this is the magnitude of charge. Let me write down mod r square. Okay, what is the r here? R is separation between the charges. Okay, okay, okay guys, let me write down charges, separation between, center of the charges. This is the center, this is the center. Okay, r is the separation between the center of these two charges, these 2 point charges. Okay, here. Okay, guys, if this q1 and q2 are both same type, or no, if q1 is positive and q2 is positive, okay, they are going to repel each other. If I say repel, then, guys, to understand these things, you should do some of the thing. First you should find the center of the charge. If this is the center of charge, this is the center of charge. Okay guys, join them. Okay, and, center, this means this is the point, this is the point. If you join these 2 points, you will form a line. Okay, so join them and form a line. Okay guys, the electrostatic force between these 2 point charges will be, along this line, will be along this line. Okay, along this line. So there are two sense. If I say along this line, then, the force may be along this, or this force may be along, in this direction. Okay, so guys, if both the charges, if q1 and q2, both charges are positive, or both are negative, or both are negative, like here, let's suppose these are negative, so negative negative. Okay, so, the direction of force is, away from each other. Okay, is away from each other. Okay, so, okay, so here, so direction of force will be away from, so this is, this is the direction which is away from each other. Similarly here, here, this is the negative, this is the negative. Okay, so direction of force will be, and this is the center. Let's suppose this is the center, here this is the center. Okay, I had joined these two center and I form a line. Okay, so, force will be along this line. Okay, since these two charges are, these two charges are negative. Okay, so the force is, away from this, let's suppose this is the q1, this is the q2. So, the force is away from q1. Okay, is away from q1. Okay, and here, this is the, let's suppose this is the q1 and this is the q2. Okay guys, and, this is positive. Let's suppose this is positive, this is negative. So, guys, here, the what is the direction of force is, if this is the center, this is the center c1, this is the center c2, the direction of force will be, toward the center c1. Okay, here, let's see, let me, yeah, direction of force will be, toward, let's see, this is it, toward. Okay, direction of force will be toward the center. Okay, you can see toward the center, this is the f. Okay, so direction of force will be toward the center. Okay guys, so, if the charges are of same side, same sign, then, the force will be away from the center. Okay, if charges are, opposite sign, then, the force will be, toward each other. Okay guys, so now here there are so many things which we can do here. First thing, who had applied this force? Okay, who had applied this force on q2? Answer is q1. Okay, q1. Okay, who had applied this force f on q2? Answer is q1. Q1 had applied. Okay, so, again, q1 will also apply, q1 will also q2 will also apply a force on q1. Okay, which is opposite in direction. So by Newton law, so this this electrostatic force you know come under Newton third law force pair. Okay, here Newton third law. Okay, so here one thing which is important is Newton third law. Newton third law. Okay, okay, guys. Here I had represent this force. In I had represent the magnitude of the force. Okay, I wanted to represent this force in vectorial form. Okay, how can I represent the force in vectorial form? Guys, if I know the magnitude of the force, if I multiplied this magnitude with which is a basically a scalar with an unit vector, then I will able to find out I will able to find out uh, a vectorial form. Okay, if let's suppose this is this magnitude is a scalar k. If this magnitude is a scalar k, so what is the vector f? Vector f is equal to basically k into which is the magnitude unit vector. Okay, and what should be the direction of this unit vector? Direction of unit vector should be direction which is along this line. Okay, direction which is along this line. Okay, so guys, what is the direction of this what is this direction? We can find it with the help of simple vector method. Okay, what should be direction of what should be this direction? We can find it with the help of simple vector method. Okay, we can find it with the help of simple vector method. And vector is geometric. So don't frustrate when you see vector. Okay, just think about it in geometrical manner. Okay, you will able to solve vector problem. Okay, so here we can find this direction with the help of vector. Okay, geometric of vector. Okay, guys, so if I know, if I can represent this line with a vector r. Okay, with a vector r, so what is the unit vector? The direction of unit vector is also along this. So I can represent a unit vector along this line is in this manner. Unit vector will be in this manner. Unit vector will be in this manner. Vector r divided by mod r. Okay, this will be the unit vector, and I should just multiply it. Okay, let me write down k1 because here k is here. So what is the f? Vector f will be k q1 mod q2 mod by mod of rq vector r. Okay, so this is the vectorial representation of the force. Okay, now come to the another important thing. Guys, this force is vector. Okay, this force is vector. Suppose you have a lot of charges, and you wanted to calculate a force on particular charge by all the charges. So suppose here this is charge, here is another charge, here is another charge, here is another charge. Okay, point charge, and you wanted to calculate force. Force on this charge by all the charges. Okay, force, what is the force on it? Okay, so what you do, force by this, force by this, force by this, and all the forces are vectorial forms. Okay, guys, so so net force will be vectorial addition. Okay, guys, and people call it so if suppose this force is f1, this is f2, this is f3. So what is the f net? F net is equal to vector f1 plus f2 plus f3. Okay, guys, and people call it superposition of the forces. I do not interested in telling name of it. Okay, and more or less this is the simple vector addition. Okay, so don't bother about this, what is the superposition of forces. Okay, guys. Okay, so this is the about force, and we'll learn about these things in more detail when we solve the questions. Okay, because with the help of theory we are not able to understand all the concept. Okay, so we'll solve a lot of question. Okay, a lot of question on electrostat. Okay, and another important property of charge is that No, charge is quantized. Charge is quantized. Quantized. What it mean that if I say charge is quantized, guys, a charge is always arise due to proton or electron, and number of proton or number of electrons cannot be fraction. A metal cannot have 1/2 electron. A material cannot have cannot have 1.2 electron. Okay, the electron in a material, okay, electron in a charge or in a material is always integral manner. Electron can be 1, electron can be 2, electron will never going to be 1.2. Okay guys, so here charge is always quantized. Okay, we'll see what some of the application. These are quite simple concept. Okay, we'll see some of the application of this. You'll see in question when you explain the numerical question. Okay guys, thanks for watching.